The angle head adapter function makes using the angle drive head simple and intuitive. The main advantage is the flexibility of use for adjustable heads. Using angle heads makes it possible to extend the capabilities and versatility of machine tools, allowing the tool to be oriented at fixed angles relative to the main spindle axis. The role of the Sinomeric angle head adapter option is to make their handling easy and flexible directly from the CNC. Their use makes it possible to machine complex geometries such as undercuts and angled holes without manually repositioning the part, allowing the operations to be completed in a single setup with greater efficiency and precision. On 3-axis machining centers, machining shapes like those shown in the image wouldn't be possible. The Sinomeric angle head adapter option integrates and optimizes the management of angular heads directly in the CNC, making them easy and flexible to use. In this video, the machining of a rectangular pocket inside a ring-shaped part is shown. Even when using 5-axis machining centers, this position would not be reachable due to clearance constraints and possible interference between the workpiece and the machine structure. Using angle heads potentially turns a 3-axis machining center into a 5-axis machine with manually positioned axes. Once you've mechanically calibrated the angle head using the digital indicator, as shown in the video, or the adjustment vernier, you simply need to enter the set tilt values into the dedicated adapter slot in the tool table, and then create a new working plane by programming Cycle 800. So, let's see where to enter the angle heads within the CNC control. You open the page corresponding to the tool table. Here you'll find the adapter slot for angle head attachments. From the close-up, you can see that there's a first slot that will hold the data for the angle head. Inside it, you can enter the specific data for the tool with the cutting part. By pressing the Further Data button in the vertical soft keys, the screen opens where you can enter the data for the angular head attachment. So, let's see where to enter the values for the angled head. All linear offsets must be considered with the head in the neutral position, meaning with the rotary axis set to the 0 position. The first L1 offset corresponds to the distance between the attachment point of the head in the spindle and the first rotary axis, as shown in the diagram on the right. The rotation axis 1 parameter corresponds to the angle at which we recorded the first rotary axis, in our case, axis C at 60 degrees. The L2A offset corresponds to the axial distance between the position of the first rotary axis and the second rotary axis, as shown in the figure on the right. The L2B offset corresponds to any misalignment between the position of the first rotary axis and the second rotary axis. The rotation axis 2 parameter corresponds to the angle at which we recorded the second rotary axis. In our case, axis B is set to -86 degrees, as shown by the digital display in the video we saw earlier. The last linear offset L3 is the distance between the second axis of rotation and the tool's mounting point with the cutting part, the data for which are defined in the tool table. The data entry screen shown is very convenient and intuitive for the machine operator. But if there are specific requirements, it's also possible to use the full screen with all the tool axis offset and vector orientation data. For example, to precisely and completely compensate for all the geometric offsets of the angle head, as shown in the example diagram. The linear distances declared in the angular head's rest position are recalculated in space by the angle head adapter function based on the declared rotation angles, and the control point is then brought back to the tooltip. The orientation in space is also automatically recalculated. Let's take a look at the programming. First, the tool inserted in the slot of the angle head must be selected directly. To be clearer, you call up the tool with the cutting edge. Next, a new workplane is programmed using Cycle 800, which will take into account the orientation defined in the tool. By setting the angles to be the same but with the opposite sign to those of the angle head, any rotary axes of the machine will not be moved because they already match the tool orientation. In the circular pocket machining example we're about to see, will have an additional tilt of the Z-axis, which will therefore be left at 0 in cycle 800. At the end of the machining process, the workplane is deactivated. In the video, you can see machining with an angle head, where the tool is set with two tilts as described earlier, a 60-degree rotation relative to the Z-axis and a 86-degree rotation about the new X-axis. Cycle 800 creates the plane perpendicular to the tool axis, and the circular pocket cycle works just like it would with a conventional spindle. Note that if needed, you can use the Traore commands in combination with toe frame for any disengagements, even manual ones. This is because the angle head adapter function identifies the tool's exact orientation using the data specified in the table. In summary, the angle head adapter feature. It extends the capabilities and versatility of machine tools. It reduces setup time and cuts down on tool changes or repositioning. It allows machining on complex geometries, such as undercuts or angled holes, without manually repositioning the workpiece. It integrates and makes it easier to manage the heads directly in Sinumerik. It enables machining operations that were previously only possible on machines with more axes. That's all for today. Thank you for watching, and we'll see you in the next tutorial.